Don't miss out on our new videos by subscribing LogicHeap and pressing the bell icon.
Hello friends, welcome to LogicHeap. In this tutorial, we are going to compare algorithms or code snippets on the basis of time complexity. So till now, when we started with comparing two algorithms on the basis of runtime, but we came to know that it may depend on system configuration. Next, we tried to do this with the processor operations. So we created two tables, input size and processor operations for both the algorithms, and then we compared them. Now we know what is time complexity, right? So let's start with comparing algorithms on the basis of it. So these are the two code snippets and we need to compare them. Firstly, we'll find the time complexity for this one. Let's name it as T1n. Okay. This operation is going to take one operation. This is going to take n plus 1 operations, right? This comparison is going to happen for n plus 1 times. This is going to happen for n times. Then we come inside this loop. So this part, how many times it is going to run? It is going to run n times because this condition is true for n times. Okay. So this statement is going to have one operation, but it is going to run for n times. So 1 into n. This is n plus 1 for n times. So n into n plus 1. This is going to run for n into n times. Now this print statement, it is inside both these loops. So n into n square, and every time there are two operations, addition and then print. So 2n square. Okay. So if we sum all of these, it is going to come as 4n square 4n plus 2. This is going to be the time complexity in this case. Now calculate the time complexity in this case. Let's name it as T2n. Okay. Now this is one operation. This is n plus 1. This is going to take n operations. This is inside this for loop. So this condition is going to take one operation and n times. So n. And this is the code of linear search. We are thinking that we will not go inside this if in the worst case. So this is the total. Now it is coming as 3n plus 2. Okay. In this case, the time complexity is this, and in this case, time complexity is this. Now you compare both these conditions, both the time complexity. So in this case, this is a linear equation, okay, and this is a quadratic equation. So if by graph also, you know, linear goes like this and quadratic gives you the parabolic curve, right? So this goes very faster and this goes slower as compared to quadratic equation. So here we'll say that this has lesser time complexity and this has greater time complexity. So this is a better code snippet or algorithm. Okay. So that's how we compare two algorithms on the basis of time complexity. Okay guys, so now let's see the second example. Let's take T1n as n square and T2n as 215n. Okay. Now you need not to calculate the time complexity. I am directly giving you the time complexities. You need to tell me that which one will perform better. So one is linear and another is quadratic. So we can think that linear is going to perform better and quadratic will take more time, it will have more processor operations, it will grow faster. Okay, so by logic we can say that this is going to perform better, and that is true as well. But someone can do this. You can try to put values of n. Here it is 1, here it is going to take 215. When n is 2 now, it is going to take 4 processor operations and it is going to take 430. So what is this happening? This is performing better in fact as compared to this. This is taking more processor operations. This is going to happen till n is 215. So for 215, it would be 215 into 215, and here it will be 215 into 215. But after this, when n becomes 216, it is going to give you 216 into 216, and here it is going to give 215 into 216. So this is better as compared to this. So after 215, this is going to perform better. But before that, this is performing better. So the point here I want to make is, don't look for smaller values. You need to look for larger values only, because we are working for the larger values of input size, okay? Not for the smaller values. For the worst cases, when your input size is very huge, how your algorithm is going to perform. So in this case also, you will see that this is a linear equation. This will grow slow. So after 215, this is going to perform better. We are not worried about the smaller values. You can understand the same thing using graph as well. Let's see. N1, 2, okay. Here we'll plot T1N. So there will be 215 at some point, 430, okay. If you draw the graph of this equation, it is going to come like this. It's a linear equation, so like this, right? With this, if you are going to draw this here, 0, then for 1, it is going to come here, it is going to, so a curve like this, right? So you see, initially this is giving smaller values and this is giving bigger values, but at some point when n will be 215, these lines will cross each other, these curves will cross each other. So from n is equals to 215, this is going to go more steeper and this is going to give you bigger values, but this is going linearly. So this will perform better after n is equals to 215. Okay, so by graph also you can understand how these are performing. So the point or the takeaway from this lecture is, you only need to consider the larger values, not the smaller values. So from here we'll start in the next class. Thank you.